Next one is the audio data. Of course, we also often do the projects in an audio category. There are several audio files such as MP3 or WAV files. So how to deal with the audio data, how audio data is going to be handled with. Let us understand. But to start with, audio data consists of sound recordings. These sound recordings can take various forms. Like text or image data, it is unstructured and requires pre-processing and transformation for analysis. To analyze an audio data, since it is what you call a pure audio raw data, we should be able to transform this into something else. To handle the audio data, there is one simple technique. Initially, we are going to convert an audio file into an image file. There is something called a spectrogram. Using the spectrogram, we are going to analyze the audio data, visualizing this as a picture. Then all the audio, the total audio data will get transformed into a image file. Then we know by using ANN or CNN how to handle the image data, how to process the image data, right? So that is what about this audio data. But dealing with the audio data is more difficult than video data. First of all, this audio, biggest challenge is to convert into image file. Right then we'll be able to perform any analyzation. Okay. So examples is speech recording, music, and environmental sounds. What are going to be used to handle this audio data? How we will be able to analyze this audio data? We are going to use the technique like Fourier transforms, MFCCs, that is called multi-frequency spectral coefficients. By using these techniques, we will be able to handle this audio data. Okay, the applications such as speech recognition, music classification, and sound event detection. I'll tell you, these days AI has been scaled into every category, every domain. Nowadays, there are projects like there are applications which are going to offer you the customized music as per your modes. You just only need to type the feeling that you're going through. Then it will be able to identify the right music to play. Earlier, there has to be a playlist, either using YouTube or some other platform. You just, when you click on the playlist or a respective song, it is going to play the corresponding song. But right now, the applications of this audio has been sprawling across entire domain, because there are a lot of projects on audio data. One such wonderful audio project that I have come across is automatic music generation. Music generation meaning there will be a model developed which get transformed into an application. When you use application, only the thing that you need to do is you just need to express the feeling that you're going through at that point of period, emotion that you're going through at this point of period. Based on the emotion, it is going to suggest you the right audio to play, a list of audio numbers or a playlist to play. This exactly is the application of the audio data. Speech recognition. Again, speech recognition is of several forms. It can take several forms. Mood detection. In the speech, there is something called a mood detection. You've been speaking in different moods, anger, or happy or sad, whatever. It should be able to identify the mood of your speaking. Okay, so our speech recognition. Maybe again, the other form that it can take is to identify male voice or a female voice. You know what exactly is the speech recognition, because we often use this in our day-to-day life. Music classification. What is music classification? For that model, you need to feed one music number. Then this music will be classified into classical, jazz, pop, western classical, or whatever. Okay, so we'll have a lot of scaling applications in data science. Next thing is the video data. What is the video data? Of course, there are a lot of things. This video data, there are a lot of applications of this video data in YouTube or the other platforms which is going to stream the videos. Now, at a nutshell, video data is a sequence of images. Generally, there is nothing as such a video. Video meaning a continuous frames of the images. Lots of images will get captured within a stipulated time. There is something called 30 FPS, 60 FPS. What is 30 FPS? 30 FPS video will be of a low resolution. 60 FPS video will be of a high resolution. What is the difference between 30 FPS and 60 FPS? It will be able to capture 60 frames per second, or it will be able to capture 30 frames per second. More frames, more details within the image, more resolution within the image or the video. Less frames, less resolution within the image. Now, as you already knew, most of mobile phones are equipped with a wonderful tool such as 30 FPS or 60 FPS, and this is one of the prerequisite to purchase a mobile phone, right? You started watching, is it 60 FPS or 120 FPS? But even the mobile phones will be able to capture as many details, rather as good as a DSLR. But here, frame rate is important. Now, anyhow, video data is a sequence of images, as already talked about the frames. The number of frames per second is going to define the clarity of the video. With associated audio, it is the rich form of the unstructured data that requires advanced processing. Here, video also combines audio. So, processing a video file is even more difficult than audio because we need to handle two things here. Number of images plus the audio file should be converted into spectrograms. Unstructured data, it is a rich form of the unstructured data, very difficult data that often to be dealt with. Okay, and examples such as CCTV footages, movies, and user-generated videos. These are the videos that will get generated to be used in our model to collect the data. As you collect the data, and how it is used in the data science. Okay, first of all, we are going to combine the image and audio data processing to analyze, to be used in our data science models. And deep learning techniques such as 3D CNN or recurrent neural networks are used for the task and the action recognition. Now there's a video. In that video, we should be able to identify what is the action that is being performed. Is it a romantic video or action video, or it just is something else? To identify the actionable events, we will use the techniques such as RNNs. RNN is somewhat very advanced, which you are going to come across in deep learning. Maybe in 2.2 or 3.1 you will have deep learning. The very first thing that you are going to learn the deep learning is the RNN. Okay, which are 3D CNNs. There is CNN. CNN will be applicable on only the images. Images will be put in the CNN model, on which there will be some convolution operations. Right then, the image will be used for some transformations. Okay, once something will get transformed into something else. But how we are going to perform the same thing on the video, because video is not a single picture. To perform the convolution operation, we'll have several pictures. 30 frames per second has to be analyzed only to identify what is the action within 1 second. Right after the next second, action may be different. Right? For that, we are going to use something called 3D CNN or RNNs to operate with, to handle the video images or video data. Thank you.